Example 2. A particle moves with acceleration function a is equal to 11 minus 4t meters per second squared. V is equal to 6 meters per second and x equals 0 meters when t is 0. We want to find the velocity function and sketch it for t in the interval 0 to 8. So we're going to integrate 11 minus 4t dt. So that's going to be 11t take away 2t squared plus a constant. We know that v is equal to 6 when t is equal to 0. And that would give us, if we substitute in, that the constant is equal to 6. So v is going to be 6 plus 11t minus 2t squared. Now, I'm wanting to sketch this. In order to do that, I might think about trying to factorize it. So I'm going to try 6 and 1, and 2t and t. If we put a plus there and a minus there, that will give me the plus 11t when we expand out. So that's what v is equal to. So we can see that v is equal to 0 when t equals 6, and of course it can't be when t is negative a half because the clock starts at 0. So that's worth noting. So we want to sketch it in the interval 0 to 8. Now, at 0 we can see it's going to be 6. We also know when t equals 6 it's going to be 0 here. So somewhere in between there's a maximum, but I don't think we need to go into that sort of detail. It's going to have a maximum because of the negative 2t squared, so we know that it's shaped like this. So it's going to go something like that. Of course, I haven't managed to get t equals 8 on there, so I might be tempted to redraw that and have it going slightly flatter. It's difficult. I haven't given myself very good axes to work with, actually. I should have had more down the page below it. So we'll go something like that. In fact, we don't want an arrow on the end either if we're just going to 8. Anyway, you get the idea without me fiddling around with it for ages. You could do a better job than that. We want to find the displacement function now. So in order to do that, we need to integrate the velocity. So x is going to be the integral of 6 plus 11t minus 2t squared. So that's going to give me 6t plus 11t squared over 2, take away 2t cubed over 3, plus some constant. But we know that x equals 0 when t equals 0, and that implies that the constant is 0. If we substitute in, all of those would be 0. So x is just going to be 6t plus 11t squared over 2 minus 2t cubed over 3. So find the distance travelled in the first 8 seconds. So that's distance, not displacement. We know that x of 0 is equal to 0. We know it changes direction at 6. So x of 6 is going to be important to us. And we finish at x equals 8. So we can work all of those out using the calculator. So let's bring the calc in. So x of 6. So we're going to have 36 plus 11 times 6 squared divided by 2, take away 2 multiplied, my fraction template back, 2 multiplied by 6 cubed, not 66 cubed, all over 3. That gives me 90. And then we want x of 8. We could just go back and edit, change those 6's into 8's. So that needs to be an 8. And back at the beginning here, I just did the 6 times 6 in my head, so it's going to be 6 times 8, which is 48. And that gives me 176 over 3. So the object started at 0, it's gone out 90, and then it's come back, so that this distance here is 176 over 3. So the distance travelled is going to be 90 plus 90 take away 176 over 3, which will be this distance just here. So that's going to be 180 take away the last answer, gives me 364 over 3 meters.